Now for a quick concept check, consider an inode-based file system with 2 kilobyte blocks and 32-bit disk and file block pointers. How large of a disk can this file system support? So we're given that we have a 32-bit disk, and that also means that we have 32-bit file block pointers. In other words, our disk can represent blocks or block numbers using 32 bits. So each block pointer is actually just a 32-bit integer, and that means that we have 2 to the 32 possible blocks. So if you were given that we had a 64-bit disk, then we would have 2 to the 64 possible blocks. Okay, so we know that we have 2 to the 32 possible blocks, and we also know the size of each block, which is 2 kilobytes. So we can simply multiply the number of blocks in our system, or in our disk, by the size of each block to determine how large of a disk this file system can support. Or rephrased, how much data can we store on disk with this file system? And so that gives us 2 to the 32 times 2 to the 11, which is 2 kilobytes, and in total, that product is 8 terabytes. Now, what is the maximum file size? For this question, we're going to look at the structure of the inode. And here it says that each inode has 12 direct pointers, 1 indirect, and a doubly and triply indirect pointer. And so we recall that each direct pointer corresponds to a data block for the file. And so each of those 12 direct pointers is going to map to a data block that is 2 kilobytes in size. And so from the direct pointers alone, we can store 12 times 2 kilobytes of data. Now the indirect pointer is a bit different, and the indirect pointer is a block number that corresponds to the indirect block, in which the indirect block is completely filled with other pointers. And each of those pointers corresponds directly to a data block of the file. When I say data block, a block on disk that's holding data in the file. Okay, so an indirect pointer points to an indirect block that's filled with pointers. And how many pointers can we actually store in one block? Well, we know that we have a 32-bit disk, which means we have 32-bit block pointers. And so each block pointer takes up 4 bytes. And we have 2 kilobyte blocks. So within 2 kilobytes, we can store 2 kilobytes divided by 4 bytes, which is going to be 2 to the 9 pointers, or 512 pointers per block. Okay, so for the indirect pointer, that's going to give us 512 data blocks, and we again can multiply the number of pointers in that block times the size of each block to determine how many or how much data we can store from the indirect pointer alone. Now we do a similar process with the doubly and triply indirect pointer, except we note that with these, with the doubly indirect pointer, for example, there are now 2 levels of indirection. So the doubly indirect pointer points to the doubly indirect block, which is filled with pointers that point to indirect blocks themselves. And so the first block that doubly indirect pointer points to is going to store 512 pointers, and each of those pointers is going to map to another 512 pointers. And so in total, the doubly indirect block, or pointer, is going to give us 512 squared data blocks. Likewise, the triply indirect pointer is going to give us 512 cubed. And so now that we know how many pointers we have in total that map directly to data blocks, we can calculate the maximum file size by multiplying the number of pointers that have a one-to-one mapping with the data blocks by the size of each block. And so that gives us 2048, or 2 kilobytes, expressed in bytes, times the number of pointers that we calculated, and that gives us this large number here.